All right, so we got a little activity that we're going to use today. I'm going to go ahead and drop this to you in a link. So I'm going to pause the video and give you this so that you can have it open and ready to play with. All right, let's get rolling. So we saw in our presentation earlier this week, if we increase the number of protons, something happens. So let's just do that really quick. We have proton. It hangs out in the nucleus, this middle area here. And as we add protons, something happens. Let's try this. So we add another proton. Interesting. Now we have helium, He. Add another one. Lithium, Li. Add another proton. Be. Add another one. Boron. So as we increase these number of protons, we change the different type of element. And again, this was known as the periodic table of elements. As I added these, I'm going to reset it. You'll notice that it reads almost like a book across the top and then down. Okay, so add one, bloop, add another one, boop, and another one, etc. And it'll read just like a book. Now, what happens if we just add electrons? Throw an electron in. Remember, they hang out floating around on the outside here. Looks like not much happens, except our net charge gets more and more and more negative. But we're not changing the type of element. The only way we can change the type of element is if we change the number of protons. Just a note, the proton itself has a positive charge. So is there any way that we could balance out these positive charges? Well, what happens if I add electrons? If my electrons match my number of protons, we get a net charge of 0. So what I'm going to have you do is play with this simulation yourself. I'm going to ask you a couple of questions, and I want you to use this simulation to answer those questions. All right, best of luck.